So we're going to get started with our first set of speakers. Our first speaker is Cara Lozinsky, and she's a PhD candidate in the Department of Civil and Mineral Engineering at the University of Toronto. And her current research focuses on characterizing interzonal air leakage in MURBs and its effects on building energy consumption and indoor air quality. Prior to starting her PhD, she worked as a consultant in the building envelope restoration and worked primarily on commercial buildings and MURBs. So we're happy to have her here. And so I'm going to stop sharing my screen now, and we'll let Cara share her screen.
Okay. Well, hello, everyone. As Noah said, my research is focused on characterizing interzonal air tightness in multi-unit residential buildings, and that's what I'll be speaking on today. So a very brief overview of my presentation. I'll start by providing an introduction to compartmentalization and what it means in the context of multi-unit residential buildings. I'll speak very briefly about how it's regulated in industry and kind of the test methods that are used to assess compartmentalization, which will lead very nicely into the current knowledge gaps and how my research really fits in with that. And then I'll just wrap things up with a brief summary. So compartmentalization. Unlike a single-family home, where all of the air exchange of the building will occur through the building envelope via infiltration or exfiltration, in a multi-unit residential building, suite-level air exchange is broken up into two components. And there's the exterior air exchange, which occurs via infiltration and exfiltration through the building envelope. But there's also an interzonal air exchange component, which can occur between suites or between suites and common areas. So compartmentalization in the context of my research really means isolating an individual suite or dwelling unit within a multi-unit residential building to limit unintentional airflow between interior zones. Now, there are a lot of benefits to compartmentalization, namely there's reduced odor and pollutant transfer, there's the potential for improved acoustic comfort. Depending on how your building is ventilated, you may also see improvements to the efficiency of your ventilation systems. And then there's also the reduced potential for pest transmission. Now, unfortunately, there is no performance-based code requirement in Canadian building codes regulating compartmentalization in MURBs. However, there are currently a few optional performance-based standards. ASHRAE 62.2 and LEED both have a compartmentalization target. And both of these performance-based standards use something called a whole suite or an unguarded blower door test to essentially assess the level of compartmentalization in a suite. And they use a target metric of Q50, which is the air leakage rate for the suite at a pressure difference of 50 pascals normalized over the entire suite surface area. So if we think back to our little cube of a suite, essentially this test measures the air leakage occurring through all 6 sides of that suite, and then it's normalized using the suite surface area. So there are a few big knowledge gaps that currently exist with this research topic. And the first knowledge gap is whether or not it's fair to assume that all interzonal boundaries have similar air leakage rates. Essentially what the performance-based standards are doing with this whole suite air leakage metric is assuming that that is representative of every single surface for the suite. However, based on existing research, we know that depending on your structure type and your building envelope, you may actually see very large differences in interzonal air tightness or air leakage rates on a surface by surface basis. And that may actually have huge implications for your actual building performance. So the first part of my research is focused on characterizing interzonal air tightness at a partition level using a guarded blower door test method. And this essentially allows us to isolate air leakage rates on a surface by surface level instead of using the whole suite metric. And this will give us more information about what boundary types are really kind of the problem areas and where we should be focusing our efforts during design and construction to ensure that we actually meet the intent of all of these compartmentalization requirements. The second major knowledge gap is whether or not whole suite compartmentalization targets actually translate to positive building performance outcomes. Now, the existing Q50 targets in both LEED and ASHRAE 62.2 aren't actually based on any research around building performance. They were simply selected because the targets could be easily met by like across a wide range of building types based on existing construction practices. So the concept of building performance never really entered the equation. It was always about what could we reasonably achieve. So the second part of my research is we'll be using a coupled multi-zone airflow and whole building energy model to systematically assess the impact of different compartmentalization levels on primarily indoor air quality, but also energy performance and ventilation efficiency, so that we can get a better picture of how tight we really need to go with these compartmentalization requirements in order to achieve the positive benefits that I talked about at the beginning of the presentation. So in summary, compartmentalization in MURBs has the potential to improve building performance across a wide range of metrics, but unfortunately the existing performance-based standards may not be sufficient to guarantee acceptable outcomes during building operation. And I think it's vital that we sort this out before these sorts of performance-based requirements kind of make their way into our building codes. And my research will hopefully provide that evidence-based support that we need to improve future code and standard updates. And so that's my presentation. Unfortunately, I won't be sticking around for the rest of the presentation. I have to jump off to another meeting, but my email is right there. And I'm sure someone from SBN would be happy to get you in touch with me if you want to talk further about my research. So thank you.